So we've spent time calculating out exactly how we would find the head of a pump force system. Now let's actually look at how we can get information about a pump from a manufacturer. And so what we're going to be looking at is a bunch of pump performance curves. And so pump performance curves, depending on the manufacturer, there's going to be a lot of different ways that they may display the data. And we're going to look at a bunch of different ways that they do display the data. But the important thing to remember is all of them are going to have how much head the pump supplies versus the flow rate that they're flowing at. And all of these will be a decaying an equation. Most of these curves then will also show you what the pump horsepower, the brake horsepower of the pump is versus flow rate. They will show you the efficiency versus flow rate. So let us take a look at, this is just a generic pump curve. And this is one of the kinds of pump curves that you would see. Now, obviously, head, horsepower, and efficiency are all going to have different axes. So if this was the curve, and I do have one that I will show you like this, typically the head of the pump will be up here. There'll be another axis here for the horsepower and another axis for the efficiency. So with a lot of these pump curves, even if they don't look like what we're used to seeing, as long as we know that we're going to be looking for head, horsepower, and efficiency on them, we should be able to muddle things out. Now, so the first thing I want you to look at is we have this point that is labeled the BEP, or the best efficiency point. It's also called the design point. So any analyses that we typically do, especially when we get into dimensionless performance of pumps, we're really going to be looking at what is the design point, what is the best efficiency point. If we don't know that when we're looking at a graph, it's pretty easy. We just find out what flow rate has the best efficiency and we work back from there. And so where this line for the flow crosses each of these curves is going to report out exactly what the efficiency horsepower head is. And so all of these are going to be based on flow rate, because depending on how quickly or how slowly the pump is moving, it's going to change all of these properties. We're going to go in, and on a couple of these curves, we're going to see multiple pumps on the same curve. So what's going on there is we're going to talk about this idea of geometrically similar pumps when we do dimensionless performance analysis. And it's basically kind of the same thing as using a model of a plane in a wind tunnel, where we're going to be able to predict what's going to happen on a larger airplane by what happens to that little airplane in the wind tunnel. But we're going to be able to do that with the pumps. And because we can do that with the pumps, we're going to be able to make a family of pumps that basically are all the exact same sizes. They've just every dimension scaled by the exact same amount. So what that allows us to do is to display more of the information on one curve, because typically these pumps will have the same efficiency. Depending on the style of pump, they may or may not. But that's typically why they will put them all on one curve, because it takes up a lot less space. So let's look at this one here. So this curve I pulled out, this is showing a bunch of different pumps. In this upper part here, it is showing the feet of head per flow rate in gallons per minute. You can see we got it marked out here. 10 gallons per minute is the design point for this pump. And this pump has a bunch of different configurations, from a half horsepower 5-stage pump all the way to a 5 horsepower 42-stage pump. This is just showing head versus flow rate. And even if they did not label the axes head and flow rate, you'd be able to look GPM and feet. We know that's head versus flow rate. You look down this bottom curve, they've separated out the efficiency in gallons per minute per percent. And they're claiming that the efficiencies for this family of pumps are all going to be the same. So here's another curve I found. I like showing this one off, even though it's a single pump with a single head loss curve. What I do like about this one, if you look at it, it's both in English and metric. So you can see here we've got meters and feet of head, and then along the bottom we have flow rate in either gallons per minute or liters per minute. So it's nice to see a graph that has both of these on it. Let's take a look at this guy right here. Now I know when you first look at this, this looks like a complete and utter hot mess. Once you learn how to read it, it's not that bad. Most of the pumps in your book are going to have this style of pump curve. And so as we look at it, we can see right off the bat there's a lot of lines going on. So let's start puzzling together what this means. And I'm going to put on a highlighter here. So the thing that we look at first is we see that we have total head and feet, capacity in gallons per minute, and then we have our lines that we expect to see that are decaying little lines here. These are our head curves. You'll also notice that they are labeled off by an inch number. So these are a family of curves, family of pumps. These are the different impeller sizes. So we have impellers ranging from 5 inches to 7 inches. And you also want to point out that most of these pump curves will tell you what RPM rating this pump curve is set up for. So let's go back to a pen here, and let's get something that's going to really stand out, a red. So let's take a look at this. Let's pick a pump, and let's say that we are running at 125 gallons per minute, and we're going to use a 6-inch pump. So here's our 125 gallons a minute. If we run this up to 6 inches, everything we're going to be doing is around that point right there, because that's where the 6-inch curve intersects the 125 gallons per minute. So this is now where we start going and taking a look at, okay, what else is going on? Let's get rid of these other highlighted lines. So now if I look over here, I see that I've got these parallel dotted lines. These parallel dotted lines are all labeled at a horsepower rating. So if we think about it, that's got to be our brake horsepower. So how do we read that? Well, now if I draw on my own dotted line here, parallel to all the other ones, that tells me where I'm at in this axis. So I'm between 1 and 1.5 horsepower. Halfway between is probably about here. And so halfway between those would be 1 1/4. And where we're at looks about halfway in between those. So 1 1/4 would become 1 3/8. So we can say that this thing's got a brake horsepower of 1 3/8 horsepower. So that gives us our head rating. So, and actually we didn't go, but if we read this over just like a regular graph, our head's right here. So we could say the head of our pump is probably about 27 feet ahead. Has a brake horsepower of 1 3/8 horsepower. All of this is flowing at that 125 GPM. So the last thing that we have is we have our topographical lines. And if you look at all these topographical lines, they're labeled a percentage. These are our efficiency curves. So it's basically what we're going to do is we're going to sketch in our own curve, probably about right there, maybe a little bit less than halfway there. So if we look at it, it's between 60 and 65, a little less than halfway, about halfway, somewhere in there. We could probably say the efficiency is about 62%. And so that's how we go about reading one of these graphs. Now, why don't we give you a chance to take a look at that? And so, why don't we look at, and I want you all to take a look at 6.5 inch impeller at 100 gallons per minute. And then we'll pick up. So find that, write down the head, the brake horsepower, and the efficiency is going to be for this guy here. So let's clean this out. So we said I want you to do it at Q equals 100 GPM. And the 6.5 inch impeller. So why don't you guys take a couple minutes to do that, and then we'll pick it up in the next video.